Thrilled you are joining this session at the openSUSE conference 2025 in Nuremberg. My name is Oscar. I'm a QA architect at SUSE, and yes, this is our recording. As you are watching this, I'm likely working from Spain, maybe even by a swimming pool. But please know that my heart is definitely there with you all in Nuremberg today. I'm really excited to have this chance to share our journey with Uyuni, a key open source project that we are passionate about building it. Over the next minutes, I will be talking about the scaling testing in Uyuni, a TestOps journey. We'll explore how we are making sure a complex, fast-moving open source project has rock solid quality by putting our quality process on autopilot using TestOps ideas. If you are interested in test automation, CI/CD, how to manage quality at the scale, or just curious about what goes on behind the scenes in a project like Uyuni, then you have found the right session. So let's get started and dive into how we are aiming for the stars with quality in Uyuni. Right. Before we dive into how we test Uyuni, let's quickly cover what is Uyuni for those who might be new to it. In essence, Uyuni is a powerful open source software solution made specifically for managing many Linux servers. If you are dealing with a growing number of Linux systems, from a few to hundred or even thousands, and find yourself spending a lot of time on regular maintenance, struggling with different setups, or constantly working to make sure security rules are met, Uyuni is built to solve these exact problems. Think of it as giving you one central view for keeping all your Linux systems healthy, safe, and set up the same way. Its goal is to give you control and clear picture of everything. One of its main aims is to automate those boring IT tasks, like patching, configuring, and checking systems. That can take so much valuable time, and by automating this, Uyuni frees up IT professionals and DevOps teams to focus on bigger, more important projects instead of getting stuck in daily operational fires. It's also important to know that Uyuni is the upstream, community-driven project for SUSE Multi-Linux Manager. This means it has a strong backing from SUSE and a lively open source community which helps drive its new ideas and improvements. Now let's talk about some of its key capabilities that make this possible. Automate patch and package management. Uyuni is great to keep your system up to date and secure easily. You can schedule updates, manage software, and make sure bugs are fixed quickly across all your systems. Robust configuration management. Using tools like Salt, which is deeply built in, or Ansible that is also supported, Uyuni lets you set and keep consistent setup across all your servers. This means you can say goodbye to different configurations and make sure your systems are set up exactly as they should be. Security and compliance. Uyuni offers tools to check your systems for vulnerabilities using information from CVEs databases. It helps you keep security rules and create reports, which is key for meeting compliance needs. And last but not least, multi-distribution support. While it has strong ties to openSUSE and SUSE, Uyuni is designed to manage many different Linux versions, including Ubuntu, Debian, Alma Linux, Rocky Linux, and others. This makes it incredibly flexible for environments with various systems. So, in short, if you are looking for a complete open source tool to make your Linux setup management easier, automate maintenance, boost security, and ensure consistency at scale, Uyuni is definitely a project worth exploring. It's this complex and important system that our TestOps journey is focusing on making sure the quality of. One of the exciting but challenging parts of the Uyuni project is how fast it's moving. We are frequently adding new features and supporting new operating systems. But this speed brings a big problem. keeping quality high and consistent. Rapid iteration inherently increases the risk of regressions and integration complexities. With many changes and frequent updates, make sure new additions work well and don't break existing things. Takes a lot of careful work. We focus on embedding quality throughout the development cycle with a strong unit and end-to-end test on pull request, backed by a continuous testing pipeline for our main branch, and for sure, good TestOps practices. This ensures faster feedback and higher confidence in every change. Before we fully embrace TestOps with Uyuni, we faced some familiar hurdles that really impacted our speed and confidence. I want to quickly outline this problem space because it's what drove our need for change. First, slow quality feedback. Developers would submit their code, but it took too long to get full test results. This means bugs were found late, leading to constant switching between tasks and in the end, slower bug fixes. It really dragged down our ability to move quickly. Next, the challenge of flaky tests. Some tests would pass, then fail, then pass again, all without any changes to the code. These were super frustrating because they made us lose trust in our automated tests. When the team didn't believe the test results, real bugs could slip through, and a lot of time was wasted chasing problems that weren't actually there. And thirdly, environment inconsistencies. This was the classic "it works on my machine" problem. Tests acted differently on different developer setups and in our continuous integration system, which ate up a lot of time. We spent too much time fixing environment quirks instead of actual code issues, creating a big bottleneck. These weren't just one-off problems. They were patterns that limited our ability to improve quality at scale. It became very clear we urgently needed more automation, especially for environments, better visibility to truly understand test data and test trends, and robust scalability to handle Uyuni continued growth. This urgent need for automation, visibility, and scalability is what truly started us on our TestOps journey. So, a super important first step in our TestOps journey was to update how we set up our test environments. We couldn't build reliable automated tests on something that was unstable or different every time. Our goal was to stop setting things up by hand and move to something strong and efficient. So we started using infrastructure as code. For Uni, we rely a lot on SumaForm. SumaForm is our special set of tools like Terraform models and Salt states made specifically for multi-Linux manager and Uyuni setups. By writing down how our test systems should be set up in code, we make sure that every environment is built exactly the same way every single time. This gets rid of a huge reason for problems like "it works on my machine." So, looking a bit closer, Terraform is the tool that actually creates the virtual machines. For us, it mostly works with KVM, a way to run virtual machines. But now we also support setting things up on big cloud providers like Amazon Web Service. So when a set of tests needs certain machines, for example, a server, a proxy, several clients, Terraform reads our SumaForm settings and automatically creates those virtual machines with the right basic features like CPU, memory, disk, network setup, etc. Once those basic virtual machines are ready, Salt takes over for the detailed automatic setup. Salt makes sure that each test system within those virtual machines is perfectly set up for its job, so for its kind of role. This includes installing needed software, setting up Uyuni parts, configuring services, and basically turning a basic operating system into a fully working Uyuni system or client, ready for testing. And the result of making this change are that our test environments are now consistent. Every environment built from the same code is identical, repeatable. We can easily take down and rebuild environments, which is key for clean test runs. On demand, we can create these complex environments quickly, whenever we need them, instead of relying on a small number of static fixed setups. And last but not least, maintainable changes and updates to how the environment is set up are tracked in code. So this infrastructure as code help us to roll out uh, in a structured way. This automated code-driven way of handling our test environments build the essential base for making our testing process bigger and better. Once we had our automated environments, the next big step was to truly understand what was happening inside them and with our tests. This is where observability and test observability in our testing process comes in. It helps us to go beyond just pass or fail to get much deeper insights. To do this, we brought together three powerful open source tools: Prometheus, Grafana, and Alert Manager. Prometheus is our data collector. Using tools like our Jenkins Porter and Blackbox Porter, it gathers a lot of information from our test runs. This includes things like how long test takes, how often they pass or fail, what features and situations they cover, and even how much of our test system's resources are being used. Then Grafana takes all that data and let us create helpful and visual dashboards and panels. It's how we see these numbers and trends, making it easy to spot patterns and unusual activity. Finally, Alert Manager sends out alerts when a specific condition is met in our data, sending notifications via email. So, what are we observing? First, we start watching our test infrastructure metrics. This helps us understand if problems in the system itself, like overloaded KVM host, some kind of a disk issue, or network issue, are affecting how reliable or fast our tests are. After that, we collect and monitor test trends and stability. We track how a specific test or groups of tests are behaving over time. Are they getting slower? Are certain tests failing often? So this ability to observe has some really valuable use for us. One key use is analyzing historical trends to identify regressions and flaky behavior. For instance, if we see a sudden jump in failures or a test that starts failing sometimes after a specific code change, our Grafana dashboard shows this right away. This helps us figure out when a problem was introduced or identify a test that needs to be fixed because it's unreliable. Another powerful way we use this is by comparing trends between different products or versions. For example, we can directly compare how well tests perform and how stable they are between our core Uyuni project and its related products like Multi-Linux Manager. This is super helpful for understanding how changes affect things as they move from one version to another, making sure everything stays consistent and helping us catch issues early that might only affect one or another version. By having this level of visibility, we can make data-driven decisions, react faster to issues, raise alerts, and continuously improve both our tests and the product itself. One of the ongoing problems when you have many automated tests is dealing with flaky tests. These are tests that sometimes pass and sometimes fails, even when nothing in the main product code has changed. It's also hard to efficiently manage problems we already know about. This is specifically important for our Prometheus and Grafana. It's a special role we have. Mm, This is a changing job where a team member checks our automated test report, and if they see a failure, they need to figure out if it's a new problem, something flaky, or a problem that's already being looked at, or or even has a bug report. Without a good system, we found that the different test geckos might end up investigating the same known problem again, which wastes everyone's time. So our first important step was to create a strong way to track these issues using a GitHub project board. This board, which we call test suite status, has different sections, columns in fact. So we have the new column for problems found recently, debugging for problems currently being investigated, a bug for confirmed problems in the product itself, test framework, issues if the problem is on the test code, and also a column to group flaky tests. Like you can see on this screenshot. When the test gecko finds a test problem that needs to be tracked, they create a card on this board. These cards follows a standard title format, which the feature name and the scenario name, and all the details from the investigation, logs, error messages, and any comments or updates are then written directly on that card. This board becomes our main reliable place to find out the status of these difficult test situations. While having this GitHub board was a big improvement for tracking issues, we wanted to do even more. We asked ourselves how we can make this information from this board even easier to see and use for the running test with Gecko, especially when they are looking at test results or the tests themselves. This led us to create a special automated tool that closely connects our GitHub project board with our Cucumber test framework. The main goal was to show the status of these tracked problems directly within our test systems. Here's how this script operates. Before any set of test runs, the script connects to the GitHub GraphQL API, and it's set up to ask for information from our special test suite status board. Then it gets the cards from the different columns like flaky test, debugging, bugs, and so on. And then it reads the card titles to find the specific feature and scenario pattern names. Then here's the really clever part. The script automatically adds Cucumber tags right into our Gherkin feature files. These tags match the column on the card on that board. So a test scenario might automatically get tagged with flaky, bug reported, under debugging, and other different tags. And then that looks like that. The effect of this automation is very important for the test reviewer. When a test fails, they can immediately see these tags, if it's already tagged as flaky or data bagging, they instantly understand the situation. They know it's likely a known problem that can quickly find the GitHub card for all the past details and avoid starting a new investigation from the beginning. This has greatly improved how efficient we are and made it easier for the team to share knowledge and help us put our effort where it's most needed. Now, a very important part of our TestOps journey in Uyuni has been putting in place a smart test selection for our pull request. I actually had the chance to talk a lot about how this works at Selenium Conf earlier this year in Valencia. I will quickly explain the main idea to you now because it's key to how we get feedback faster. The problem we faced, like many others, was that running all our tests for every single pull request takes a huge amount of time and uses a lot of computer resources. This often means developers have to wait a very long time for feedback, and much of that feedback might come from tests that aren't even related to their specific changes. We asked ourselves, how can we smartly pick only the tests that truly matter for a given set of code changes? Our answer is to use code coverage data to make this choice. It's a three-step process. First, we connect our tests to the code. We regularly run our tests using tools that check code coverage, like Jacoco for the Java parts of Uyuni. This makes detailed reports showing exactly which tests check which specific pieces of code, like methods or classes. When they take this information and save it in a way that let us search quickly, for example, we are using a Redis database, and then when a pull request comes in, we look at it carefully to find the exact code changes, the code, the files, the methods, or classes that have been changed. And finally, we choose and run the test that we are selecting. We use the information from the pull request to search our code coverage map. This tells us exactly which tests are connected to the changed code, and only this small specific group of tests is then run to check the pull request. The benefits are big because developers get feedback much faster and it's more helpful to their changes. We use our continuous integration resources better, and we are certain that we are testing the right things at the right time. This is a system we have built into a GitHub Actions workflow for Uyuni. Then, beyond testing code on pull request, we wanted a way to always see how well the important parts of our product were working. And this is where synthetic monitoring comes into our automated test process. First, we defined the important product actions and how well they should perform as fitness functions. A fitness function is basically a way to measure how well a specific part of our system meets its design goals or users' expectations. So, how do watch this? We have made a special Ruby code that can, for example, measure how long it takes for a system to bootstrap or how long it takes for a system to be onboarded. Another very important one for Uyuni is how long it takes to synchronize products. This code gets these times by reading logs or asking information through Uyuni API or command line. Then our quality intelligence handler, using the metrics collector handler, sends these measurements like system bootstrap duration seconds or product sync duration seconds to our Prometheus push gateway. This data then shows up in Grafana dashboards, like the one you see here. By constantly watching these fitness functions, we get early warnings if a main product feature starts degrading. For instance, if the product synchronization time suddenly jumps up or bootstrap times slowly increase. It's a clear sign of a possible problem with the overall product health, even if all individual tests are passing. This method helps us see any bad effects on what could be the customer's experience and encourage the team to investigate and make improvements before problems get big. It's about making sure the whole system is healthy, not just that each small part works correctly. So the benefit is provides early warning for product level health degradation and ensure continuous insights into overall system performance. Another important part of our TestOps journey, and something that really helps us work better and together, is how we have made our integrated development environment, so the ID setup, and the process for new developers much simpler. This helps both experienced team members and new open source contributors. We have all had this problem. It's a pain to set up a complex development environment on your own computer. Dealing with it works on my machine issues, or spending days just trying to get a new team member ready to work. To fix this, we are using dev containers. These are like ready-made Docker environments that your ID can open and use. This makes sure everyone works with the exact same setup. We have made two main dev containers for Uyuni project. First, the Uyuni dev container. This one is for developing the main Uyuni product. So it's Docker files, installs things like the correct Java version and IB and other tools needed to build Uyuni itself. The dev container.json file also sets things like environment variables, for example, Java Home, and commands to run after the container is created, like running an IB build to get necessary files. Second, we have the Uyuni test container. This one is just for developing our many tests, so the test framework. Its Docker file installs Ruby, Cucumber, WebDriver, like Chrome Diver, and all the other tools needed for writing and running tests. The dev container.json for this one setups different environment variables that point to the test systems that we are registering, that we are registering on the server, registries, and settings for our test framework. So a developer simply opens the Uyuni project in their ID, like Visual Studio Code or RubyMine, and if the ID sees a dev container setup, it offers to build and open it. In just minutes, they have a complete, consistent environment with all tools and needed files installed and set up. This is perfectly aligned with everyone else on the team and our automated systems. The benefits are huge. Setting things up is much easier. We have greatly reduced problems related to different environments, and new contributors can start coding incredibly fast. It really helps everyone focus on developing rather than struggling with their computer setup. It's important to say that this dev containers work is ongoing. We are always making it better. We are actively encouraging our developers and the wider community to use them, as we believe they make it much easier to contribute and improve the overall experience for working on Uyuni. A main idea for a health open source project is transparency. This also includes how we show the quality and stability on Uyuni. We want to build trust and responsibility with our users and those who help us. Right now, we have a complete Uyuni test suite that runs every day in Amazon Web Service. These tests are started and then and the test report are shown and looked at through Jenkins systems. But that's inside our own network, the internal network. So this is great for our internal team, but the problem is that these details reports are not easy for outside people of the wider community to see. So to make this better, our goal is to make our test reports available for everyone. We believe this is key for building a stronger trust and openly showing our commitment to quality. This is still a work in progress. We are actively creating a way to share these daily test reports. The plan is to then put the reports on a public website, and this way, anyone who is interested can see the latest status of our test, understand what is passing, and get ideas about the ongoing quality for Uyuni. Our goal here is clear: to openly show the quality of Uyuni. We think this will not only encourage more people from the community to get involved, but also strengthen our promise to deliver a strong and dependable open source solution. Beyond our current TestOps practices, we are actively looking at how artificial intelligence can make our quality work even better. This is still new and experimental, but we see exciting possibilities in a couple of areas. First, we are excited to explore how AI can improve our smartest selection. This is part of our Google Summer of Code project that I'm mentoring this year. While our current smart selection works well, we think AI could make it even more exact. And by teaching a model using past data and other information that we will be exploring, the idea could potentially find the AI could potentially find with even greater accuracy which specific tests are most important to run for any given pull request. This would make our feedback loops even faster and more efficient. And then from the other side, we are looking into AI-powered test report analysis. The idea here is that when a test suite shows an error, an AI agent can immediately start working. This isn't just passively looking at data. The system is designed to connect through SSH to the specific targeted systems that involved on that failed test. Once connected, it gathers special evidence made for that system role. Some kind of logs and some kind of system details like CPU or disk. So, for example, it might collect specific service logs from Uyuni server or client registration details from a client machine. So, the AI then looks at this collected data and tries to give an early idea about what might be causing the problem. So, putting this information directly into our XML test reports. This could greatly speed up how fast our engineers find and fix problems by giving them very relevant context-aware information. These are early days for using AI in our unit testing, but it's an area where we are very interested in and experimenting with to push to limits of what's possible in automated quality checks. So, as we wrap up, What are the main things I hope you take away from our Uyuni TestOps journey? First, and most important, this was not an overnight transformation. Our progress towards quality on Autopilot has been a story of small, iterative improvements. We didn't try to boil the ocean. Instead, we focused on making incremental changes, learning from each one, and building upon that success. Second, it's crucial to understand that TestOps is more than just implementing new tools or scripts. It's truly a dual-fold shift. It's a cultural shift within the team, fostering closer collaboration between development and QE, making quality a shared responsibility, and cultivating a mindset of continuous learning and improvement. And yes, it's also technical evolution. Strategically, adopting automation for infrastructure and testing, gaining deep observability into our processes, and implementing smart solutions like targeted test selection and synthetic monitoring. If you're looking to enhance your own quality engineering practices, I encourage you to view TestOps as an adaptable set of principles, not a rigid prescription. Start by identifying your most significant pain points, introduce changes incrementally, and tailor your approach to your project specific needs and context. You don't have to do everything at once. In the end, building a robust, scalable, and efficient quality process, achieving that sense of quality on autopilot, is an ongoing journey. It's built step by step through consistent effort, a wish to adapt, and a commitment to both the cultural and technical aspects of TestOps. Thank you.